Can everyone see my screen? Hello, can everyone see my screen?
Yes.
Okay. Okay, so hello everyone. So we will continue on the aircraft fuel system. Okay, first let's do a bit of recap. So yesterday we have seen the general overview of the fuel system and what are the basic components utilized in the fuel system. So here is the schematic diagram of a fuel system for General 3 tanks aircraft. In this system, we have fuel tanks, which are main wing tanks number 1 and number 2, and also the center tank, which are interconnected to each other and to the engine through the line and fittings. Next, we have valves along the line that is used to control direction of the flow and also to stop the flow. When the valve is in cross position or perpendicular position, the flow at that particular line will stop. Now if you guys notice, there are white objects with arrow along the pipeline. There are that that are also valves, which ensure that the flow to be one directional. Means the flow is only forward. There is no turning backward. If in the case of pump dies. So next, the flow is driven by pumps that are installed at the end of the fitting and line. If you guys notice also, there are also pumps at the engine. They are called engine-driven pumps. While the pump at the tanks are called booster pump. During flight, both pumps operate with engine-driven pumps sucking the fuel, and the booster pumps helps to ensure positive fuel feed to the engine. Next, there are also filters installed at each pump to stop the debris or foreign object from entering the system. And lastly, we have a oil heat exchanger installed in the system. Although it is not shown here, it is used to reduce the oil temperature and also increase the fuel temperature. So next, we will look into refueling and defueling. So basically, refueling is filling the tank with the fuel, while defueling is removing the fuel from the tank. For refueling the aircraft, the fuel is usually refueled through the refueling point, or sometimes called refueling station. This method is this method to refuel through the refueling point is called the pressure refueling system, where pressure is used to pump the fuel into the aircraft tanks. Usually, maximum pressure used for pumping the fuel is 50 psi. The fuel pump will be automatically dispensed into the fuel tanks as required. If you notice here, the fueling station has three different lines that are connected to the three tanks. Different aircraft have different configuration of its refueling points. Some aircraft has its refueling point located at the bottom of the wing, while some, for example the ATR model, has its refueling point at the bottom of the wing near the fuselage, located here. So when refueling, there is a vehicle called ramp refueling truck that connect one of its hose into the underground. In the underground, there are storage for fuel tank called fuel farm. It is common that airports have fuel storage underground. Besides using the ramp refueling trucks, tanker trucks can also be used. Tanker trucks that directly transport the fuel. The ramp refueling trucks connect each other hose to the refueling point of the aircraft, directing the fuel into the aircraft. The refueling process can be controlled through refueling control panel that is located at the fuselage belly. Usually for most airplanes, they are located here at the under the belly, and for ATR the same also. It is located here. So now for defueling, it is typically
Before
done.
you go there,
Okay,
Ryan,
okay,
go back to the slide. Normally the control will be at the refueling point. That means for this one, the wing there, where is the browser connected, the host connected, there is the control panel there, refueling panel, right?
oh, okay.
Yeah. So it's not far from the host.
So if the refueling point is here, so the control panel will also located here.
Yep.
Sir.
Yep.
Oh, okay, okay.
Only ATR will be slightly different.
Oh,
It will
okay.
be later you will see the design of the ATR. One is at the fuselage, the control panel is at the forward, the refueling point is at the half. Okay.
Okay, okay.
Okay, the first sentence, fuel from the pressure refueling system. Where is the pressure from?
Um, it's from this ram truck.
Yep, it's either from the truck or from the Bowser. Normally we call the fuel truck, we call it Bowser, right?
Oh, okay, okay.
Bowser is the one with the tanky at the back. Like normally you see at the road there's a big round thing at the back. There's a tanky. We call it Bowser, right?
Oh, okay, sir.
Right. So not all airports have this fuel farm at the bottom of the tarmac, right? Or apron. Only very big airport and also well-designed airport. If not, this one, the fire.
Oh,
It
okay,
might
okay.
cause fire, safety reason. Normally,
Okay,
the small airport, they use the Bowser.
okay, sir.
Right. Okay, proceed.
Okay, so we continue. Now for defueling. Uh, Defueling is typically done when the plane is on the ground. Defueling is done for the following purpose, which are for maintenance of the fuel system, or when the fuel level gauges are to be calibrated, or when the staff are working on the aircraft where equipment used may generate heat or spark that may cause flame, and also when the aircraft is to be shipped or stored. The fueling process is usually followed by strict regulations, that is to reduce the risk and also maintain the safety, such as the aircraft must be at several distance from any building before de before defueling, and also the staff are prohibited from smoking and etc. Fuel can be drained through the refueling point, which we use for refueling, the same point we use for refueling. This point is sometimes also called refueling and defueling point. As we can see from the picture, the there is manual defueling valve that is located near the refueling or defueling point. When open, it will allow the fuel to flow out through the point, since the line connecting the point to the three tanks are equipped with one-way valve. Here we can see there are one-way valves, so the flow cannot flow back through this line. So fuel will be drained through another line that is connected to the manual defueling valve here. Defueling process can be controlled through the same refueling control panel, as it has defueling option also set at the control panel. A booster pump then can be used to pump the fuel into the tanker. Booster pump will help to push the fuel inside the tank out out of the tank into the tanker. Okay, so now we will look into the fuel dumping, or also known as jettison. This is some additional information, since when we talk about fuel drainage or fuel defueling, there is another action of removing fuel from the aircraft, which is called as fuel dumping or jettison. Jettison is the intentional or controlled jettison of fuel from an aircraft during flight. This system is usually equipped for large aircraft. It is not commonly used and on not usually equipped on small aircraft. The difference with the defueling is that jettison is done during flight, and it does not drain all the fuel, only until adequate level. Usually, it is utilized when overweight landing happen to reduce the weight by dumping some fuel. To control the amount of fuel that is dumped, aircraft is equipped with with detector. Here, when we see the picture, there is a low level float switch. This is mainly used for the aircraft that is equipped with a fuel dumping system, where when the fuel is dumped, when the fuel reach a certain level and the low level float detect the level, it will stop the fuel dumping system, because if it continuously dumping the fuel, will be no more fuel in the tank. But here we can also see high level float switch. This is usually equipped for all aircraft because it is used to automatically close the refuel valve when the tank is full during refueling. Okay, now let's look at the fuel system flow during normal engine operation.
Before that, any question?
Ryan,
Oh, okay, hello.
hi, can you hear me?
Oh, yeah.
I have a question about the control panel. What does it control for?
Mm, okay. Mainly, the control panel has option for it has option for fueling, refueling, and defueling. Um, I think it sets the because here when
You have the picture or not? No.
oh no sir.
Okay. I think it's easy for you to show the picture later on. Never mind. Never mind.
Okay,
We
okay,
can update later on.
okay, okay.
Okay, at the refilling panel, there will be gauges that reading what is the fuel in each tank. And then there will be a switch. There's means an on-off switch to open the valve. Let's say number 1 tank, number 2 tank, and the center tank. Whichever valve you open, you allow the fuel to go into that tank. You can see the refilling valve there. There's the refilling panel. There's a switch, and there's a check valve to flow one way. So it depends on which tank you open, the fuel will go to that tank. And also is to monitor if your tank is full already, you can switch off. Normally it's not full. Let's say we ask for 5,000 kg. This means we have to balance each tank 25,000, 2,500 on number 1, 2,500 on number 2. So when you reach number 1, normally number 1 will reach first because and number 2 tank will reach the level first because it's very near the refilling panel. So normally we have to control and switch off number 2 first. So the remaining will go to number 1. When you reach 2,500, we will switch off. So no fuel can go into the tank. That's how we control the panel.
All right. Thank you, sir.
Yep. Ryan, maybe
Yeah.
the later slide you can add in this control panel.
Okay, sir.
Let them see how it works.
Okay,
Right?
I'll add later.
Hmm.
Okay, thank you, sir. Okay, so let's continue.
Before that,
Oh,
any more questions?
okay.
Go back to the slide.
Slide before.
Yep. So normally when we use fuel dumping or jettison,
Uh,
Nazrul, when do we use this system to dump the fuel? Why we need to dump the fuel?
Because normally the fuel dumping will be switched on if the aircraft want to land in order to overcome the overweight landing happen.
Yes. When do we do that? Normally, normal flight, they will calculate the fuel already. So anybody? Ryan, do you have any update? When do you use this jettison or fuel dumping?
I think during the descending or approach, because fuel dumping system is designed for the aircraft to be able to maintain its flight at the 10,000 feet for
No,
45 minutes.
no.
Oh,
Okay. Since you bring this up, I need to ask this question. Right? Normally, for any aircraft, there will be a takeoff weight and a landing weight. So normally they will calculate already how many for this trip from KL to KK, I need this much fuel. When we land at KK, there should be the weight of the aircraft minus the burn fuel should be this much for me to land. So it's all calculated that my landing speed with the weight, my landing speed is how much. If not, you will be overweight landing already. Right? So this fuel dumping is not practiced for every flight. It's only on emergency. Let's say after you take off from KL, right? Something happened. You want to return back to land back to KL, but your weight is very heavy, so you need to dump the fuel. That's when the fuel dumping is done or jettison to dump the fuel to reach your landing weight, so you can land back at cool after takeoff. Any question? Understand?
oh, so the fuel dumping will never be used. For example,
Yes.
we uh, we we are from DKI to KL, so when the plane lands in KL, there is no possibility to use fuel dumping.
No.
Oh, okay,
It's not used because you already calculate how much weight you're gonna take already. So the landing takeoff weight and landing weight there will be they have to calculate the weight, right?
okay.
So after you take off, you have to maximum weight. That means plus the fuel. The fuel go there might be 5,000 to 6,000 kg. So in case of anything happen, you want to turn back, you have to burn this fuel. You have to let go this weight. If not, it will be very heavy for the landing. The structure will not take it. Aircraft design, there is a limit for the landing weight. Right? Normally, the landing weight is because of the due to the fuel. Right?
Oh, okay, sir.
Understand, you guys?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
So this one is emergency. That after you take off, something malfunction, you want to turn back to the original airport or land at other airport, but you need to comply with the design landing weight, so you don't damage the structure. So you have to. The only thing you can dump is the fuel. That's why we dump the fuel. And this one also you have to go to the auction there and dump it. You cannot dump anywhere. Right? There's a very strict regulation on this. Right?
Okay, sir.
So I have questions, sir.
Go ahead.
So how about if the aircraft want to do the ditching in the ocean? So does the aircraft need to dump the fuel also?
If you dish to the water, why you need to dump? It's already
Oh,
an
okay.
emergency already. Nothing
Okay,
to
sir.
help already.
Okay.
Unless you want to land at the airport, that means you have to comply with the landing weight of the aircraft to minimize the damage of the aircraft. Right?
Oh. Okay, thank you, sir.
You already want to dish into the ocean already. Why you want to save anything? The main thing is to save people life already. Aircraft cannot be saved once landed at the. Once you dish into the sea, nothing can be held already. Because everything will be underwater, all will be damaged already. Right?
Oh.
And your sea is corrosive. So all the metal cannot be used already. It's exposed to corrosion. Right?
Okay, sir.
Oh, sir,
Yeah, go ahead.
untuk fuel dumping ni, do we need the pump to dump the fuel also?
Is it settled there?
I'm sorry, sir.
Ryan, any pump there?
I'm not sure, sir.
Okay. So normally you see normally at the fairing of the flaps. So normally you dump by the gravity and the flow of the wing. The outside pressure will be low. Your inside the pressure of the tank will be high. So you will jettison out. That means the fuel will jettison out. You know the meaning of jettison?
The fuel dumping.
No, jettison. Jettison is I think maybe you can look up. I think it's using the differential pressure and also the gravity because of the wing create the inside the tank and outside the tank there's a deep pressure, so the fuel definitely will rush out. Right.
So the pump will not be required for this system. sir.
Don't require any pump. Right.
Correct.
You need a valve to open and close only.
Alright, thank you, sir.
Anything else? If not, Ryan, continue.
Okay, sir. Okay, so let's continue. Now we will look into the fuel system flow during normal engine operation. Here is the brief description on how the fuel flows in the system during normal engine operation. So to make it simple, fuel will flow from tanks, which is driven by the pumps. The fuel will be flowing into the pipeline towards the engine. The concept is tank number 1 will feed engine number 1 and tank number 2 will feed engine number 2, while for the center tank they will be equally divided to the both engines. So that's how the flow should be. Yeah, it's just simple as that. During normal operation, the both engine-driven pumps and also the booster pumps will operate. The engine-driven pumps will suck the fuel through the lines that are connected to the tank. They will suck by the it will be sucked by the engine-driven pump. So while the booster pump, which located at the end of the line, will provide helps to ensure positive feed of fuel towards the engine. Positive feed here, uh, to ensure that the flow is directed towards the engine and no flow is backwards, because when the plane is flying there may be some movement on the fuel, since this system is quite large. um, when some movement occur, there the fuel in some section may have instability. So uh, instead of uh, instead of relying on the engine pump to suck all the fuel into the engine, they will be helped by the booster pumps to ensure that the flow can be can be directed towards the engine to reduce the disturbance. It's like the engine-driven pump is pulling while the booster pump is pushing the oil. Usually, the booster pumps is low pressure pumps, while the engine-driven pump is high pressure pumps. Usually, the booster pump operates from 20 to 50 psi, but it gives a high flow rate. So the fuel flow through the line towards the engine. We can see the direction from the arrow given here. All it's directed towards the engine. So one-way valves are installed to ensure that the flow cannot return in case of pump stop operating. So in general, the fuel from the tanks will enter the pipeline, then it will be driven by the pumps flowing through the valves towards the engine. For that, anybody have question? If no, I continue. Okay, so now we will look into the normal fuel usage sequence. Okay, so in normal operation, after takeoff, usually not usually, it must be the center tank fuel to be consumed first, then followed by the wing tank's fuel. Why is that occur? As plane fly, lift is generated on the wings. When the center tank is consumed last, there will be drastic change to the lift to lift-weight ratio. Since wing is empty, more stress will be applied to the wings to support the weight of the plane fuselage. That is why this sequence can help in counteracting the bending stress of the wings. Usually bending stress here is referred to the location at the inner wings near the fuselage where the highest bending occur. Uh, the cons the operation is semi-automatic through the switching on the booster pumps. The tank consumption sequence will be operated semi-automatic. So when the center booster tank operates at higher pressure than the wing tanks, thus it will allow the center tank to be consumed first. So when the center tank is consumed, the fuel at the center tank is consumed, there is a component installed in the tank called the scavenge jet pump. So the scavenge jet pump here is connected to the bottom of the center tank. So when the center booster pump can no longer pump fuel from the center tank, the scavenge jet pump will pump the remaining fuel into the number 1 tank. Then the main wing tanks, both wing tanks, will start to feed the fuel to the engine. It will replace the center tank. Okay, next. Okay, so this is the addition to the fuel consumption as informed yesterday or before. In a typical tanks configuration of two-engine aircraft, main tanks at the wings are divided into inner tank and outer tank. This is done because as we can see the picture here, this is the schematic configuration of the inner and outer tank. This is outer tank, this is inner tank. At first, all the tanks are full at this level, at the same level. So the outer section will remain full until the inner section is consumed until this level, until this predetermined level. Then, when the inner tank reach this level, the outer section will be slowly consumed by gravity. It will be transferred to the inner section. So this operation sequence will help to reduce the wing bending stress. So next we will look into the fuel system control panel. So in general, the aircraft fuel system is operated semi-automatically. A switch on is required to be done by the pilot. Of course, in different aircraft, there are different configuration of the control panel. So, and also it may be not as simple as this at the real aircraft. Yes, so at the control panel, there is it has the selector switch of each main tank booster pumps. If you notice, the control panel is designed according to the configuration of the fuel system. So this left booster pump, a left switch here represents the left booster pumps here, and also the right switch here represents the right booster pumps. At the control panel, there are also warning light that is used to indicate the condition of the booster pumps. When the pump fail or switch off, the low pressure warning light will turn on. Okay, next. The control panel also has a switch for the center tank booster pumps, and also it same as for the main wing tanks. It also has the warning light indicator. In the fuel system, there is a component that is located in the wing tanks that is called the suction valves. Suction valves here. This is used to allow the gravity-fed operation or engine-driven pump suction in case of both booster pumps here fail or of one tank here fail. So this will allow the fuel in tank to be fed through gravity and also through the suction by the engine-driven pump. Besides that, the control panel also has controller for control switch and indicator light for the crossfeed valve here. The light indicator will be turned on when the crossfeed valve is open. So should be horizontal here, then the light will be turned on. And also in the system there is also temperature sensor that is installed in the number 1 tank here. It will detect the temperature and transmit to the indicator for the pilot to see the fuel temperature. Oh, by the way, in the aircraft, the left side of the airplane is referred to as number 1, while the right side is referred to number 2. Means the left wing is number 1 wing, right wing is number 2 wing. This right engine is number 2 engine, left engine is number 1 engine. Okay, so in the system, there are shut-off valve that is installed and located in the line before the engine. Here is the shut-off valve. It is mostly open at normal times and only closed when engine is on fire to stop the fuel from flowing into the engine. Engine this shut-off valve, engine fuel shut-off valve, is closed through the fire handle, which is usually used when engine is burning. In some aircraft, shut-off valves also may be open or closed through the selection switch, which is used during normal engine start or shutdown procedure. So next, the fuel valve close light, as usual, will be turned on when the valve is closed. So again, in the system, uh, there is a component that is called APU bypass valve that is installed at the line of number 1 tank. It is installed to allow the APU to take fuel from number 1 tank if no booster pumps are operating. But the APU can also take fuel from any tank if the booster pumps of the tank is switched on or selected. Also, besides the APU bypass valve here, there are also APU fuel shut-off valve. Uh, Actually, APU also consume fuel through what is called the APU fuel feed system. Usually, APU receive fuel from tank number 1. Most aircraft have standby fuel pump for APU. So the APU shut-off valve here is typically operated by the APU automatic start or stop sequence. Means usually the operation here there is another control panel, and usually the operation here is automatic. Depends on the APU. Okay, so now let's look into the crossfeed valve operation. So what is the importance of this crossfeed valve? Why is it installed between the lines? So when the crossfeed valve is open, the crossfeed valve will allow both engines to be fed from one fuel tank. This is usually in case of booster pump failure on one tank or fuel tank imbalance correction procedure. So let's say the left left tank booster pumps fail, so it cannot provide flow into the engine number 1 or provide enough flow to engine number 1. So to help provide enough flow for engine number 1, the crossfeed valve will be open or will be placed horizontally to allow the fuel from the tank number 2 to feed both engine number 2 and also engine number 1. When also open, it can also feed one engine from both tanks in case of one engine malfunctioning. So let's say this engine is malfunctioning, so the shut-off valve will be closed and no more fuel will flow into the engine number 1. So the fuel in both tanks will be directed towards towards the engine number 2. So from the crossfeed valve, just now we see about the fuel imbalance. So what is fuel imbalance? It is basically a condition where the fuel in one tank, the difference of fuel in both tanks are too great or have great difference of the quantity of both tanks fuel. So how to correct the fuel imbalance? First, we need to open the crossfeed valve to make it horizontal to allow the flow. Then switch off the pumps in the tanks that have lower fuel level. Means the right tank here has lower fuel level, so the pumps here needs to be turned off. Thus, the system at the right tank is in low pressure. So, the temporary fuel supply to the engine on both engines will be supplied by one tank, which is usually the higher fuel level. In this picture is the left tank. So when the switch of the booster pumps of the right tank is closed, so the both engine will temporarily consume the fuel from the left tank until the imbalance is corrected, until the balance is achieved. It is to be noted that the sequence mentioned here is very important because when when we switch off the pump first before we open the valve, it may lead may lead towards engine fuel starvation. Means that when the valve is still closed but we turn off the pump, there will be a shortage, cut off of fuel. When the engine doesn't get any fuel even for a short moment, that is called the fuel starvation. So it is important to open the closed feed valve first so that there is fuel flow, there is flowing towards the engine. Then we shut off the booster pump at the right. So after the fuel imbalance is corrected, pumps are switched on first before closing the closed feed valve. It is to be noted that this sequence also must be followed. So what I read is it is to ensure that the tank to engine configuration is followed. Basically it's tank number one feeding engine number one, tank number two feeding engine number two. So to ensure the system is to be maintained, so we need to follow the sequence when the fuel imbalance is corrected. Oh sorry, the topic should be the fuel operation before the engine start. Until now what we see is the fuel operation when the engine have started. So what about when the engine have not started? So how does the engine got the supply of fuel since the engine have not started? So during engine starting process, there is not enough power to start the whole system. So how to supply fuel to the engine is through the electric driven pump here, that is driven by electric power from the battery that is utilized to provide early supply of fuel to the engine. When the electric pump is turned on, it will bring the fuel flow. It will provide the fuel flow towards the engine, and then some of the fuel will return through the return line here and provide flow for the feeder jet pump, and then the process will slowly continuously progressing. The electric pump will be used until it reach a certain pressure, usually at 4 psi. When the flow pressure reach 4 psi, the feeder jet pump here, or, or any pumps that except for the electric pump that originally switch off will be turned on when the flow reaches 4 psi. As the pressure achieved, okay, so as the pressure achieved for psi, the electric pump will still turn on until it reach about 8 psi. Then the electric pump will be turned off, and then self-sustained. Then the engine has achieved self-sustained power that it can power this system by itself. Okay, so this additional information, different aircraft has different configuration and different design, so they also have different fuel capacity. So for example, for ATR, one wing require about 3,185 liter, so about 2,500 kilogram. So for two wings can add up to 5,000 kilogram. For Boeing, since it is a large aircraft, it has capacity of 200,000 plus liter. So as the Boeing 737, it also has large capacity since both are large aircraft. So okay, that's all from me. Any question? or any term you guys don't understand?
Hi Ryan,
Hello.
I have a question.
Okay.
For the CrossFit valve tadi kan, it says that CrossFit will be used to balance the wing bila booster tank failure.
Sorry, apa tu?
Untuk CrossFit valve operation, it
Okay,
will be
okay.
used bila booster tank failure, right? The pump, booster
Okay.
pump.
Yeah.
Okay, so dekat fuel imbalance tu, can you go to the fuel imbalance punya slide?
Okay ni.
Okay, dekat bawah tu dia ada cakap pumps are switched on. So what pumps are switched on after the correction?
Oh, okay. For the when fuel imbalance occur, let's say the left tank is higher than the right tank, we switch off
Mm-hmm.
the right tank because we switch off the right tank to allow the fuel from the left side to be consumed first until it reach the same level as the right tank. So what we turn on here is the right pump.
Oh, okay.
Because
So means that after the valve is already closed, the pump that is on the right side lah.
yeah. No,
So what?
buka pump dulu baru tutup valve dia.
Oh, okay. So they are using only the right side punya pump and fuel, is it?
No, when the imbalance is corrected, they use both pumps.
Oh, okay. Okay.
Because later this valve will be closed, so yeah, they will use both pumps.
Okay. Alright, thanks.
Okay.
Oh yeah, I have another question.
Okay. Boleh.
For the inner tank and outer tank, right?
Oh yeah. Okay.
Just now you said the fuel will be pumped into from the center tank to the tank number 1. So where the fuel from the center tank go? Is it the outer tank or inner tank?
Okay, fuel sequence gini. When fuel is consumed, the center tank will be consumed first, then the wing tanks. When the
Okay.
center tanks habis kena pakai, so the fuel tanks will change to the wing tanks.
Okay.
Okay, so when the system is starting to use the wing tank, originally they are the same level. This is inner tank, this is outer tank. Center tank is already consumed, no more fuel. Okay, so originally they are the same level, but because we have problem when there is no balance of weight in the wings, there are things called the bending stress. We want to reduce that,
Okay.
so we set a level here. So when the inner tank here is consumed until this level, until it reach this level, then the inner tank will not be consumed until it habis lah. So the outer tank will be consumed first when it reach this level. This is to maintain the this is to help to reduce the wing bending stress.
Okay, so means that the scavenge jet pump tu dia akan pump the fuel just to the wings lah, so it doesn't matter where it goes.
Ya, scavenge jet pump dia kena install dalam tank number 1. Dia connected to the center tank. So when the center tank dah kena consume, tak semestinya habis bersih lah dalam dia. So dia nak pump fuel yang selebihnya tu ke dalam fuel tank number 1. So yeah.
So kalau dia pump the fuel to the first tank, right? Bukan dia akan create imbalance kah dekat situ?
For this, because the system is like that, I looked to some system and they stated that the scavenge tank will drag the fuel from the center tank to the tank number one. But I think because tank number one also is used for the APU system, maybe there is some balance in that, because as fuel number one tank is consumed, some of the fuel of number one tank is consumed from APU, it get the replacement from the center tank.
Oh, I see. Okay.
Or maybe if there is some imbalance. Okay, about the imbalance of the fuel, it is not necessarily both tanks have to have the equal quantity. There are
Mm.
allowable limit. I think the limit about not too small, about 100 kilogram, also hundreds of kilogram. So it doesn't matter if there are difference about several hundreds in both tanks.
Okay,
Maybe
so
it's the imbalance.
the
Okay.
difference tu dia tak akan affect performance of the aircraft lah.
Sepatutnya macam itulah, sebab dia ada setkan limit. Seandainya terlebih limit, so imbalance correction operation can be done lah.
Okay, alright. Thank you.
Okay.
Okay, I need to add on this.
Okay.
You have to look on the design of the wing. This is just two dimension. You have to see the three dimension of the wing. After the imbalance is why we don't want imbalance is we can have imbalance, no problem. But just imagine your one side of your wing is 3,000 kg, one side of the other wing is 2,000 kg. So during flight, what do you think? Which wing will be lower?
The heavier one will be lower.
Yep. So it will cause what? It will cause aircraft to yaw
Yeah.
or to roll due to the heavy. So pilot will try to balance the thing so he have a level flight. That's why we don't want much imbalance, too much imbalance of the wing, left and right.
Okay, sir.
Yeah. So either the outer wing first or the center wing first, it doesn't matter. But the booster pipe is always at the lowest point of the wing and near to the engine. So you supply a feed to your engine. Right. Any other question?
Hello, sir.
Okay.
Yeah, go ahead.
Okay, Fida.
Oh, no question from me.
Oh, okay. Why do we need the outer section, or why do we have inner and outer tank?
Why do we have inner and outer tank? I think this is given by Ryan. Ryan.
Oh, okay.
Yeah.
Okay.
I think one of your slides explain why we need the fuel in the tank, right?
Yeah. Okay, I explain. Okay, simple. When we see the picture here, inner tank and outer tank is divided by a barrier. Actually, this barrier is not completely blocking the fuel in the tank. There are some spaces between the barrier. This is placed. This is installed to dampen the movement of the oil, because when the plane is moving, so does the oil. Oil will be moving because there are space above the wings. So
I talk about fuel, not oil.
oh yeah, oil. Sorry, fuel. Okay, so in the fuel tanks, there are spaces above the fuel. So when the plane is moving, so does the fuel will move. So to reduce the impact of the movement of the fuel, we place a barrier that separates the outer tank and also inner tank to dampen the effect, to reduce the effect.
Faham? Evelyn? Evelyn?
Not really.
Okay. I give you an example. Kalau satu botol, you get a mineral water bottle, right? You drink half, you lie it flat, that means horizontally, not standing up. If you move the water will go out. You will slish. Go to the other side, you will push the water to other side. You push to other side, kan? You can imagine. What is the term? Splash or what? How to say that? Kalau kita goncang itu bottle, the water will go side to side, kan?
Oh,
And
Yeah.
then if you go to if your aircraft maneuver turn, you roll. So if there's no barrier, then all the fuel will try to go to other side, and you will create some turbulence inside the wing. So we don't want it to happen. We want it
Oh.
to be dampened, right? So to minimize the splashing of, how we say, splashing or swish float. How to say that one in bahasa Malaysia? Anybody? Right. So macam kita goncang itu mineral water, half water, lying flat, the water will go to other side and will try to push the water to more to other side. Kalau itu air dalam itu pergi ke sebelah kanan, the water will go to the kanan, kan?
Oh, yeah.
Yeah. So we want to dampen this effect on the aircraft, because if aircraft one wing during roll, it go one wing high, one wing low, all the fuel inside will try to push to the lower wing. So your aircraft will slightly move to the other side. So we don't want that effect. I don't know how to explain this effect.
Inertia.
Something like that. If your water is flowing, it's the best example is mineral water half, like you go and play with it, right?
Okay, sir.
Shahida, your mic is okay, right? No question from you all this while.
Hello.
hello.
Okay.
Sorry, just now I have a bad internet connection, but I have a question regarding the fuel imbalance just now. So, when supposedly to do the fuel imbalance correction, is it during flight?
Yeah, during flight, because fuel imbalance can occur during flight.
Oh, okay.
Consumption may occur. Yeah, difference in consumption may occur during flight because engine is running.
Mm.
But the imbalance can be allowed at a certain limit. But if exceed that limit, the imbalance must be corrected.
Sorry?
Oh, the imbalance can be allowed for a certain limit. Ada limit imbalance boleh terjadi lah. Kira kalau lebih limit, so imbalance kena corrected lah. Because it's simple operation, just turning off the pumps and also opening the crossfeed valve until the imbalance is corrected. Then can operate like usual, like normal.
Oh, okay. Thank you, Ryan.
Okay. Ada soalan lagi kah? Kalau ada tanya aja.
Ryan,
Hai.
saya lagi.
Coba.
Fuel dumping tu kan tak semua aircraft ada sistem tu kan?
Not all.
So, kalau
Usually
yang
large
aircraft tiada sistem tu apa ada orang mau buat?
I think because sebab fuel dump. Okay, fuel dumping biasa large aircraft kan, so weight of the aircraft lebih besar lah kira. So usually small aircraft, yeah, I think small aircraft is lighter. They won't have that much impact compared to the larger aircraft.
Okay.
I think something like that.
Okay, Hafida.
Yes, sir.
Don't worry about fuel dumping or this thing. Aircraft is designed with, right? No aircraft have this fuel dumping. And also, if you dump fuel, not all the fuel will be dumped, right? It just have to, all the aircraft is designed to have a maximum takeoff weight and a maximum landing weight. So it just need to be dumped until we have the landing weight, maximum landing weight that we can land the aircraft safely, right?
Right.
Okay, for small aircraft, the maximum landing weight and takeoff weight is almost the same, right? There's not much different, right? To say that also, normally we don't carry, aircraft don't carry full weight of the fuel, right? Only when you fly long distance, let's say here to New York, then you have to carry a lot of fuel. Other than that, you don't require. Like 73, normally when you take off from KL and land in BKI, actually you also can land in KL also. There's not much difference. But for larger aircraft, you are taking a lot of fuel, let's say from KL to London, right? You are taking 18,000 kg of fuel, right? So this is already exceed the limit of the landing weight, right? Maybe they just have to dump a bit only, like half of it, 10,000 kg, that's all, or 5,000 kg. Okay. This is in case the aircraft have going long distance and the fuel they take is above the maximum landing weight.
All right. Okay, sir.
Yeah. That's why don't worry. Normally most of the aircraft don't, like the aircraft for shorter route, like here to KL and like BKK to Tawau, Lahadatu, they don't take much fuel. Even though the maximum fuel they can take is 15,000, they maybe take 5,000 fuel only. So they are within the landing weight limit. So they no need to dump fuel.
Oh, okay, sir.
Yeah. It's not that every aircraft isi penuh minyak, right? No, aircraft don't isi penuh punya minyak every time. They only refuel, the fuel is refuel up to the requirement only. Because additional weight of the aircraft, the weight of the aircraft will cause more fuel. You will need more power. So we don't want to burn extra fuel.
Oh, okay.
The lighter, the better. So they normally take only the required, they will calculate only the required fuel only for takeoff and to reach the destination. Yeah. Nobody will take the fuel maximum, because if you take 5,000, your weight is additional 5,000. You take 10,000, additional 10,000. What for? But you are burning, the engine had to work, how to say, work harder just to give you the enough lift to carry the additional weight. Right?
Alright.
So, hope you guys faham. Macam you punya kereta, you kasih duduk penuh orang, then you use a lot of fuel lah. If satu orang saja, then maybe you punya 20 liter fuel, you can go for 7-8 days. If tiap-tiap hari penuh orang, then you only maybe 3 or 4 days you kena isi minyak lagi. Right? So we don't want to burn additional fuel. Fuel is money.
Okay, so I understand.
So I have question.
Go ahead.
Is it possible for aircraft to occur the fuel imbalance during the aircraft 1,000 feet to land at the runway?
Repeat again.
Is it possible the fuel imbalance happen to the aircraft if the aircraft is 1,000 feet to land at the runway?
Sorry, that's not my mind. I mean, 1,000 feet to the runway is less than 1 minute for the aircraft. So the imbalance, like I said, imbalance doesn't mean 10 kg, 20 kg, right? Depends on the design. You are more than 100 kg or 200 kg, right? So for this to happen is unlikely, because when the aircraft flying, the design of the aircraft, if there's one side imbalance more than how much, you can feel the aircraft trying to rotate already, to roll already, because all the wing is heavy on one side. So to answer, 1,000 to land, fuel imbalance is very unlikely. Because you will feel it straight already during cruise, right? They will keep on checking. Before land, they will check all the fuel is available, left hand, right hand, proper. Then they will start their descent and approach, right? So 1,000 feet to landing, nobody will do anything. They only prepare for emergency already. Right? 1,000 feet to landing is less than 1 minute for the aircraft. Right?
Yeah. Okay, thank you, sir.
Any other question?
No, sir.
Okay, as we go through all these things, if you guys study the previous slide, any question, try to bring it up, right? So everybody can have a better understanding. And this one, the few one, after that you got question, try to bring it up so Ryan can do more work and research.
Okay.
Right, Ryan?
Yeah, yes, sir.
Okay, there's one thing missing from your thing.
Okay.
Because refueling is very volatile, then the risk of fire is there, right? So there's a lot of warning during refueling. Ryan?
Okay.
Yeah. So I think we give you the study that what are the warning or caution during refueling, what to be done, what are not to be done, all these things. Inside the manual, the Twin Otter manual. You read at the caution, it's good you put it inside here, or maybe the next few days when we have time. Try to look at the warning, the caution for during refueling.
Oh,
It means Bowser, the guy must do what they wear, what are the things before they start connecting the hose, what are they are supposed to do. They are supposed to ground the browser to aircraft, ground the browser to the ground, aircraft to the ground, all these things. What that is a very good safety warning, safety on this, right?
okay.
Yeah, try to look because when we bring you guys to the apron, you see the activity during the refueling. You will see what this guy doing, why this guy go and connect here, connect there, check here, check there before he even start the refueling.
Okay, okay, sir.
There's a lot of warning caution there. Yeah, it's good that you read it up or you read it up. Okay.
Okay, sir.
So tomorrow is who?
Sorry, sir.
Tomorrow is who? What subject?
Oh,
Yeah.
Nazrul, the ice rain.
Ice and rain protection, sir.
Ice and rain protection.
Yeah.
Okay. Okay. Tomorrow 3 o'clock I have a meeting. So we start at 2 o'clock. Okay.
Okay, sir.
Okay, okay,
Yeah.
sir.
Then I try to arrange whether Thursday you guys go to hang out. Right.
Okay,
I
sir.
try to talk to the foreman there, engineer there, tomorrow morning. Okay.
Okay.
Okay, thank you, sir.
So arrange you guys go there. Right.
Okay,
Tomorrow 2 o'clock. Right.
Okay, sir.
Ice and
Can,
rain protection.
All right.
Okay, sir.
Right. Yeah.
Thank you, sir.
Thank you, sir.
Anybody
Thank you, sir.
under MCO?
No.
There's few places in Sabah got
No.
MCO kan? Tak ada
yeah.
kan?
So far mungkin tak ada.
Ada yang
Oh.
keluar.
Tak ada? Oh, okay. Right. Okay. See you guys tomorrow.
Okay,
Okay.
sir.
Okay,
Thank you,
thank you, sir.
Bah. Sorry Nazrul, termakan masa Nazrul.
Nggak apa-apa. So,
Kenapa?
saya kalau present ambil 30 lebih menit lah kali ya. 30 menit lah.
Okay, okay.
30 minit. So, kalau macam kami pergi hangar, kami bila lah present ni? Jangan beritahu kita.
Kasih sekejap je besok Nazrul biar dorang dua present besok sekali.
Jangan mau pergi ambil vaksin nih.
Oh, jangan.
Ada
Tapi
yang
saya rasa lama juga lah 30 menit kali ya.
besok
Belum masuk Q&A kan?
Q&A lagi.
Masuk soalan lagi.
Ya ada yang belum vaksin nggak sini?
Baru first dose.
Oh, oke.
Ryan sudahkah?
Oh, saya sudah di SICC sampai.
Oh. Nazrul?
Ya, saya sudah. 2 dos sudah.
Oh, okay. Bah, jadi jumpa
Oke,
esok.
Jadi tidak apa-apa kan?
Oke lah.
Oke, oke, oke.
Hati-hati
Alright.
kamu.
Oke.
Thank you guys.
Oke, thank
Thank
you.
you.
Thank you. Bye.
Oke, bye-bye guys. Ya, jangan lupa subscribe, ah.